Hi, I'm going live just a little bit early so that uh, I've noticed that sometimes whenever I go live, it has to reset a bunch of people's connections. So I'm going live a little bit early so all the connections can be reset and everybody can solve any issues with getting back to the stream and not have to worry about missing anything while it resets. So we're just going to take a moment and wait for them to come back. I will write up some formulas for resistance. So this is formulas for dealing with resistance that I'm going to write up. I will explain them once we actually get started. Let's see. Oh, that's where's my. All right. If it's identical resistors, you're going to take the value of the resistors and divide it by the number of resistors. Um, any two resistors, you can do product over sum, which will be product, which is multiplication, over sum, which is and then any resistors you can do uh, oh shoot, that's wrong. Plus 1 over you can also write this out as you have a reciprocal button on your calculator. It looks like this. It's directly above the 7. You can use this to input open parentheses R1 to the negative first power. You hit that button to get to the negative first, plus R2 negative first plus R dot dot dot, as many resistors as you want to the negative first. You close your parentheses and do one more to the negative first power. That is how you will do that one. This one right here, let's grab a box. Let's make it kind of a small box. This one right here is my preferred method of doing things. Alright. It's been a couple minutes. I'll get started on the quiz. The total resistance of any number of parallel resistances, all having the same value, is equal to the value of any one of the resistors divided by the total number of resistors. That's what we're doing here. the value of any one of the resistors divided by the number of resistors. This means if you have two 50 ohm resistors, you would just do, if you have two 50 ohm resistors, you would do, that's a box still, you just do 50 divided by 2, and that's 25 ohms. That's it. That's all you have to do. That's, if they're identical. Now, having identical resistors is like having the stars align for you, so that's not going to be a reliable method. Sorry, I heard something going off. Adding additional resistors in parallel with those resistors already existing in a parallel connected circuit will always increase total resistance. We covered this last lesson. Adding additional legs to a parallel circuit will always decrease the resistance. It's the same thought, like it's, remember the checkout lanes. If you open another checkout lane, that decreases the resistance to getting out of the store, no matter how shitty the checkout person is. There's more people are going to get out of the store for every lane that you open up. Oh, skipped one. A circuit contains 580 ohm resistors in parallel. What was the total circuit resistance? Well, all we have to do is 180 divided by 5. That's 36. Should be 36 ohms. Got a lot of different answers. But the answer is 36 ohms. I know probably everybody got this one wrong. Like it told them they were wrong. And that's because I copy pasted the ohm symbol as the answer, and that's not correct. That's my bad. Alright, two lamps are connected in parallel across a 120 volt source. Each lamp has an internal resistance of 96 ohms. What is the excuse me, equivalent circuit resistance? So that's just 96 divided by 2. 48. You put 48 ohms, you got it right. So most of you did. Good job. Use the product sum method to solve for total resistance on the circuit containing one 25 ohm and one 15 ohm resistor. Okay. So product over sum. So we have a 25 ohm and a 15 ohm over 25 plus 15. So that's R1 and R2, R1, R2. So all we have to do is plug times 15, 375. So 375 over 25 plus 15, that's 40. So 375 divided by 40 gives us 9.375. See how we did. 9.3464. That's weird. Because that's like close, but not remotely. 9.375. Okay, we got 375. That's weird. Alright, so good job. Almost everybody got that one. When can the reciprocal method be used to calculate total resistance in parallel circuits? The reciprocal method can always be used. Any combination of parallel resistances. So whether they're, going back here, any resistors, as long as they're parallel, you can use the reciprocal method to find their total. I prefer, like, this is a lot, like, these are three different formulas, and it's a lot to remember, remembering all three formulas. You could just remember one of them, and unfortunately, it's the most difficult one, which is the reciprocal method. But that's my recommendation, is that you memorize the reciprocal method and don't bother with these other ones. For two resistors to be in parallel with each other in a circuit, there must be blank current paths. I must have copy pasted somehow twice. So there must be two current paths for it to be parallel. That's it. Oh, we didn't have a question in here about, hey, use reciprocal method. So let's go back over here. So let's do these numbers. So you're going to plug into your calculator, and I would use the calculator the school gave you, or another good quality calculator, not just like a 4 function, because you need this reciprocal button. You're going to open your parentheses. R1 is 25 to the negative first power plus, and this negative 1, that's telling the calculator 1 over 25. And then plus 15 to the negative first, that's telling it 1 over 15. Then you close your parentheses and go to the negative first power. And that's telling it all of that 1 over, which is the basic formula. Yeah. So that is what you work with, and it should give you that same 9.375 ohms. I can show you maybe. Well, this has this button. It's not the same. Scientific? It doesn't have it still. I mean, it kind of does, but okay. 25. Well, that's clear. Open parentheses. 25 plus 15, close parentheses, and then do it one more time. There's 9.375. Hit enter. So that kind of gives it to you right there. It's not, this calculator isn't great for it, obviously. I still typed in the same buttons, like did the same button presses as you would do on your calculator. Except on your calculator, this button is right here, right above the 7. Alright, so do not forget to go get your test and finish your test and drop them off in the next 2 hours. Make sure you have finished both the last tests. Yeah. Hopefully I gave y'all plenty of information. You have the books, everything. And there will be a test there for you to pick up. So remember to do that. Alright, and I know a lot of people don't watch this live stream, so I've started including a question in the quiz that happens during this time. Let's see. Let's go back to results table. We're still waiting on Jacob. I give him a couple minutes. I will probably let's look at my drive. I think I have some parallel circuits worked up. Electrical theory. DC theory circuits. Parallel. Are they actually parallel circuits? Hey, yeah, okay. I might. Oh, this is just one page. It's good enough. I might work the. I'll work some of these in a little bit. Maybe sometime over lunch, just to have a video up of working with these. Yeah. Oh, that wasn't the right button. I'm already on the. All right. My vacuum kicking off means it's oh, I left Socrative. Gotta log back in. It is time for this to end. So let's finish. And I will start. Oh, y'all aren't second years, y'all are first years. DC Theory 3, Ratios and Proportions. Go ahead and go to the school and get your test and do this one. I will see you guys at 1:45. Alright. Alright.